Okay, so we did the chapter on waves. We looked at simple waveforms, longitudinal, transverse, orbital, and we learned a little bit about tsunami. And obviously, the next chapter has to be about tides, right? The cutest thing about tides, I think you have all heard about tides. Maybe you haven't learned about the processes or the forcing that produces tides. So where do the tidal forces come from? That's the main new information in this chapter, at least for some of you. Okay, so tides are obviously known for a very long time, even going back to pre-Christian era or before the Common Era. And it's all in English words there are which use related expressions like good tidings, tiding someone over, or going against the tide, and so on, right? Only in the 1700s, when Newton discovered the theory of tides and put down gravity and how the Earth-Moon system produces gravity, that we really learned the details about tides. And the other interesting thing in this chapter is, even though Sun is so much bigger than the Moon, the tidal forcing is mainly from the Moon, not the Sun. Why? We'll see that this has something to do with the distance from the Earth of the Sun versus the Moon. So in this chapter we are going to learn what tides are. They are obviously long, regular, shallow water waves. Okay, if you can imagine, wavelength is very long, so L/2 is greater than the depth of the ocean everywhere, so they always feel the bottom, just like the tsunamis. So tides are shallow water waves, something to remember. Tides are caused by gravitational attraction of the Sun, Moon, and the Earth. So even though the solar tides are less than 50% of the strength of the lunar tides, they can have constructive interference and destructive interference to produce extra strong and extra weak tides, just like the wave interference we talked about. And there are different tidal patterns, diurnal, semi-diurnal, mixed, and so on. That comes from the Moon's orbit around Earth, right? How long does it take for the Moon to orbit around Earth, and how long does it take for the Moon-Earth system to orbit around the Sun, and so on? All these things matter. What are tides? Basically, they are periodic rising and lowering of the sea level, but they can also occur in your coffee cup, in the lake, and they occur daily. Just like Coriolis, the tidal forces in the lakes and your cup of tea are very small. Isaac Newton's gravitational laws explain the relationship for the first time. But early sailors, remember we learned about the early explorers, the early sailors did know about tides, okay? And they knew it must have something to do with the Moon, because it would coincide with the new moon and the full moon. Okay, so before we get into tide generating forces, I'm going to close this introductory podcast here. It's only about 3 minutes, but just to remind you, we're going to learn about how the tidal forces come about, why the lunar tides are much stronger than solar tides, how they can constructively interfere the solar tides and the lunar tides, and where the periodicities of the tides come from. Okay, very good.